In this quick tutorial, we'll look at how to convert a decimal number to hexadecimal. Now there are a couple of different ways of doing this, but the easiest and most reliable way by far, especially when you're under the pressure of an exam, is to actually convert the decimal number to binary first, and then convert the binary number to hexadecimal. So let's see how we do this. Let's take, for example, the decimal number 98. Now we're going to convert this decimal number to hexadecimal, but first of all we'll need to convert it to binary. So what we'll do is we'll set up our binary table. So 1, 2, 4, 8, 16, 32, 64 and 128. Now if you're not sure about converting to or from binary, then there are a couple of other tutorials on this channel and in this playlist so that you can check those out. For the moment though, we'll look at how to convert this binary number, assuming that you know how to do this anyway. So 98, obviously we don't need 128, we will need to use 64. 64 and 32 makes 96, so we'll use that. We're missing 2, so we'll stick that in there, which means of course we can simply put zeros in all the other columns. So our binary number is 0, 1, 1, 0, 0, 0, 1, 0. So that's step 1, to convert the decimal number to binary. Now once we've done that, what we need to do is to split this binary number into 2. Now remember that 8 ones and zeros is known as a byte. Half a byte, 4 ones and zeros, is commonly referred to as a nibble. And so by dividing this byte into into 2 sets of 4 digits, we've created one nibble here and a separate nibble on the left. Now because this is a separate nibble, we need to restart the numbering system along the top. So I'm going to rub out these numbers here and restart instead the 1, 2, 4 and 8. So I have one nibble here, another here, and that's why the numbering system starts again. Effectively, we're thinking of this group of 4 ones and zeros as a completely separate number now to the 4 ones and zeros on the right. Now, once we've done that, we can simply convert each of these numbers to a decimal number, effectively. So almost as though we're going back to the 98. But of course we're not, because the numbering system along the top is now different. So what does this binary number 0010 translate to when you convert it back to decimal? Well, of course, all we do is we add up all of the numbers that have a 1 written underneath them. And so in this case, that simply is 2. On the on the left-hand side, we do the same thing. So each of those columns that contains a 1 underneath them, we add up. So in this case, we're adding 4 and 2, which makes 6. 6, 2 is our answer. In other words, 98 in base 10, or hexadecimal, is 62 in hexadecimal. So 98 in base 10 decimal is 62 in hexadecimal. And that's how to do it. But of course there is a slight problem, because sometimes you will find that the numbers along the top don't actually add up in the way that we need them to. So let's have a little look at an example. So I'm going to start off here with the 2 nibbles. I'll draw the line down the middle so we can see these as 2 separate numbers, and I'm going to write some 1s and 0s underneath them. There we go. Now if we were to take this example and add them up, let's see, we've got an 8 plus a 2 plus a 1. And that would make 11. But the problem is we're only allowed one digit here. Similarly, on the left-hand side, we have a problem. 8 plus 4 plus 1 makes 13. And again, we're not allowed to have two digits. We can only have a single digit. There we are, 13. So what do we do? Well, the thing is, hexadecimal is base 16. We know that base 2 binary only has two digits. That's 0 and 1. Base 10 has 10 digits. So that's 0 through to 9. So what on earth does base 16 have? Well, yes, it has 16 digits. So what are those 16 digits? Well, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's 10 digits, but we've got a good way to go yet. So what do we come to next? It's A, and then B. Apologise, my stylus isn't working very well there. C, D, E, and F. There we are. For some reason the stylus isn't working very well. Apologise for that, but hopefully you can see. We've now got 16 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So whilst we understand the value of the numbers 0 to 9, what do these mean? Well, we just keep counting. So in hexadecimal, the value of 10 is represented by an A. The value of 11 is represented by a B. The value of 12, a C, 13, a D, 14, an E, and 15, the maximum possible in hexadecimal with a single character, is F. So once we've carried out this calculation here and we've got these two numbers, we need to now work out what those are in our hexadecimal number line. So 11, well, let's start from 9, then count 10, 11, that's B. So we need to write that as a B. 13 is 2 more, that's a D. And so the answer to the question of what this number here is in hexadecimal is that it is written simply as DB. Let's just try one more example to make sure that we're clear on this. So let's just try another binary number. So base 10 number. Let's have the number 121. So that's in base 10, that's decimal or denary. Step 1 is to do our binary number line. 1, 2, 4, 8, 16, 32, 64, and 128. We then convert this number, 121, into binary. So we won't want 128, we will want 64, we will want 32, so that's 96 altogether. Plus 16, so 96 and 16, so that's 106, 112, plus the 8 brings us to 120, plus the 1 would make 121. So put in the zeros in those columns, there is our binary number. Next, what we do is split that between the 16 and the 8, so we have 4 ones and zeros on the left and 4 ones and zeros on the right. Now, because we've split this into two separate numbers, two separate nibbles, we have to restart this numbering system along the top back from 1. So we write 1, 2, 4, and 8. And now we need to add up the numbers that contain a 1 under them. So here, 4, 2, and 1 makes 7. 8 and 1 makes 9. which means 79 is our answer. 121 in base 10 is 79 in hexadecimal. So this is how to convert from decimal to hexadecimal using binary as the mid step. Just remember that when you are adding up these digits here in each nibble, if the answer is greater than a single digit, so if it's more than 9, then you will have to work out which of the letters A to F you will need to write instead of the number. So A would be 10, F would be 15, and simply write out that number line as I did so that you know exactly which letter corresponds to which value. If you have any questions or problems, please do leave them as a comment below, but I hope this tutorial helped you to identify the method to use in the exam for converting from decimal to hexadecimal.